Hi everybody, and thank you very much for joining us here at the Microsoft Power BI UK user group. My name's Leon Gordon, and I'll be your host for this evening / afternoon / maybe mornings session. It's been a while since we've been back with you, but obviously it's good to see you after the holiday break. Now, as always, this is going to be a very interactive session, so the Q&A will be open very shortly, and we do expect you to ask questions throughout. Shortly, I'll introduce you to our host, and we're very thankful and privileged to have with us today Bryant Avey. Now, Bryant Avey is going to take a look at integrating Neo4j within Power BI, and this will touch on some fantastic Power Query functionality and also some machine learning as well. So I'm looking forward to this great session. And just before I do pass over to Bryant, I'll just give you a brief introduction and a little bit of background on Bryant as well. So some of you may know that Bryant is a solution architect, and he's been consulting for over 30 years. He's also the CEO for Internuntius, and I hope I've pronounced that correctly, which is fantastic. I'm on a roll straight away, which is good. It's a consulting firm that he founded in 1997. So Brian has been published in over a dozen periodicals, including Chief Executive Magazine, where his article "Building a People-Centered Culture in a Digital Age Environment" was featured as the CEO Challenge of the Month. And some of his other publications include the Employee Benefit News and American Management's Association Manage magazine. As I say, Brian, absolute privilege to have you with us, and I will hand over to you now for your session.
Cool. Thank you very much. I'm going to share my screen, and we will get started here. So cool. Let me get that set up. All right. So again, welcome everybody. It's my pleasure to be here. Honestly, I'm thrilled. I'm in the United States, so it's noon here, and I understand it's early evening over there where you guys are. So good evening to you guys. I'm going to be talking today about, like Leon mentioned, integrating Neo4j with Power BI. The purpose of this session really is I'm going to use Neo4j to find hidden patterns in data, and then we're going to use Power BI to extract those hidden insights, that hidden data, and explore it visually over kind of time series. And basically, this is what I call a pattern-driven insight. So we're going to use a combination of Neo4j and Power BI to do pattern-driven insights. I will say too, and I have a slide at the end as well with my contact info. If anybody does want to connect with me on LinkedIn, just let me know that you guys attended this, and I will for sure connect with you. So very happy to do that and grow the community there. The first question that many people are asking, and you may not be familiar with graph databases, with Neo4j. And so one of the first things is like, what in the world is Neo4j and what's a graph database? I've got a really brief, quick, short video that I'm going to play, and I think I shared this with the audio. Hopefully I did that right. But let me play it real quick, and then it describes really fast just what Neo4j is and how it can help build build relationships and uncover hidden patterns. So.
Neo4j is the #1 database for connected data, built from the ground up to leverage not only data, but also data relationships. Neo4j is a native graph database, which makes it critically different from other data stores. But what does native even mean? Neo4j is designed around a simple yet powerful optimization. Each data record or node contains direct pointers to all the nodes that it's connected to. These direct pointers are called relationships. All the information needed to find the next node in a sequence is available in the node itself. The native storage layer is a connected graph. That's what native means. Because of this principle, Neo4j doesn't need to compute the relationships between your data at query time. The connections are already there, stored right in the database. Because of this, queries of densely connected data are orders of magnitude faster. Other databases don't save direct pointers between records. They need to compute connections by searching through a separate data structure called an index. This lookup process, which has to be done repeatedly to find each connection, is extremely expensive and gets exponentially slower as the data size and query complexity grows. This makes them inherently slower than Neo4j for relationship-intensive queries. Over the past decade, Neo4j has made graph databases a key technology powering modern applications for hundreds of Fortune 500 companies, government agencies, and NGOs. Neo4j is used to detect fraud, enhance artificial intelligence, manage supply chains, gain a 360-degree view of data, and much more. Learn more at neo4j.com.
Okay, so I'm gonna get started here. So as Leon said, I am able to kind of take questions and stuff too. So I'm gonna cover real briefly just some of the overview of the data so you guys know what we're dealing with, and then we're gonna dive in and look at some things, and then do some Power Query things and such like that throughout here. We're gonna be using Power BI maybe in a way that everybody isn't hugely familiar with. We're going to be doing a lot of work in Power Query, and then we're also going to be using Power BI itself to do to really do our analytics and really do our discovery work. So I want to showcase how to use Power BI in that way. So let's dive in. I don't know if any of you guys are do any trading in the stock market or interested in stocks or options trading and that kind of thing. If so, then this is probably going to be of particular interest to you guys, because what I'm pulling in is daily stock price data from TD Ameritrade. And I will say at the beginning here that in no way is anything I show here to be construed as financial advice or trading advice or that kind of a thing. I'm just simply showing you how to use these technologies to get pattern-driven insights, right? So so have to say that little disclaimer. But what we've got here on the left is this is a graph of Microsoft's stock price history, and it's 1 year. And so what you've got is each of the dots is a daily price of Microsoft, and it's connected through nodes to each price. So we start at the beginning of the year, go all the way through, and then we end at a node over here, which is the end of the year. And so this is the way I've chained this together, and I'll show it to you live inside of Neo4j here in just a second. But that's what the price data looks like. And then what I've done, and the reason that I've pulled the data into Neo4j is because we want to run some graph data science algorithms against the data. We want to find out if there are hidden patterns in the data that we don't know, and that from data that's not there, but that's potentially available to us. And so specifically what I've done is I've used two areas in Neo4j's graph data science algorithms. I've used a similarity algorithm, which is a machine learning, artificial intelligence machine learning algorithm that goes through and finds similarities. And I'm specifically focusing in on volume. So volume that's traded on different days between different stocks, and looking for volume similarity. And then I'm grouping those volume similarities into communities, communities of similarity, if you will. And so there's these community detection algorithms as well. And so we can look at different stocks that have similar volume on different days, the same stock on different days that have similar volume, to see if there's anything in there that we can discover or look at that might help, in this case, our trading platform. So when we're done, after running those algorithms, what we end up with is a graph that shows how different stocks on different days interact or relate to one another based on their similarity. So here you can see we've got Microsoft that has similar volume with Facebook, Nvidia, Alibaba with Tesla, with Cisco and Disney and a bunch of other ones. Okay, and then when we look at it like from the top view and look at everything, we see this big hairball of relationships. These are all the stocks that I have in the database, about 34, I believe, stocks that I'm analyzing. I think I've got roughly, I started in 2019, so I've got almost 3 years of data, 2.5 years of data in there. And so you can see that we basically create all these new relationships through these algorithms, and it creates this rich data environment for us to explore in Power BI. So let's we'll dive into that and look at that in just a second. But before we do, I want to kind of frame everything so you can see where Neo4j and Power BI kind of fit into things. So when we look at things from a perspective of data insights, we basically have two sections. So we've got a matrix here where we've got patterns and we've got entities. And so we've got known patterns and unknown patterns, known entities and unknown entities. So when we break that down, the thing that we're very familiar with and that we work with in Power BI and in most relational database is, we know the entities, we know the data, and then we also know the patterns. And so we run queries, and this is our tabular schemas, right? Now, when we have known patterns, but we don't necessarily know who fits those patterns. These are where we're writing queries, or we've got these outliers and anomalies. An example of this would be, say, sales quota. We know that we've got salespeople that have a sales quota, and that's a pattern, right? But we're not sure which entities, which salespeople are meeting quota and which ones aren't. So we want to see those outliers and see, hey, make a dashboard or a Power BI report to show me these outliers and show me, which people are not meeting my sales quota. Okay, but what happens now when we have unknown patterns, where we don't know the pattern at all? Okay, when we don't know the pattern, but we do know something about the data, we're in an area of data insights called pattern discovery. And so this is essentially, this area down here is what I've done with the stock data that we're about to look at. We didn't know if there were patterns in there, so I ran some machine learning algorithms to discover and create patterns based on these algorithms. And so so we're doing pattern discovery. Now there's another situation where you don't know the patterns, and you also don't know the data as well. You're not sure what you have in there. This is an exploratory type of an insight, and you typically will move from exploratory down to pattern discovery, and then moving it over into outliers and anomalies and different things like that. And there's sort of a process there. So to kind of group these things, you can see pretty plainly that the stuff on the left hand side, and then where we know the patterns, this really is where Power BI really excels at and is really good at, right? Visualizing and things when we know the patterns. But when we don't know the patterns at all, this is where you need something different, something additional to help identify and figure out what those patterns are. This is where Neo4j and a graph database really come into play. So specifically, what I've done for our data set is I've run two algorithms. The first one is called k-nearest neighbor. And the k-nearest neighbor algorithm is it's a BI algorithm that basically creates relationships, and in our case, between the stock price history, using the volume to find out similarity between the volumes, okay, on all these different stock trading days. And then we write that data back to the graph. Once that's written back, then we use a Louvain algorithm, which goes through and detects communities and networks of similarity. In this case, using the k-nearest neighbor, it creates a community, and we end up with this basically groups and subgroups of communities based on our volume similarity, and that's what we're going to explore in Power BI and take a look at it in a time series. Okay, so let me real briefly go and show you what Neo4j looks like, so you guys can see that, other than just the static pictures. By the way, the script on the left here, this is the actual, in Neo4j, there's a query language called Cipher, and this is the actual screenshot of the script that I actually am loading in the TD Ameritrade API, pulling in the open, close, high, low volume, and timestamp data from TD Ameritrade. So let's go dive into Neo4j real quick, and I'll show you. So here I'm in Neo4j desktop, and this is the browser, the graph browser, and I'm in the Neo4j database, and you can see that nodes, I have 23,610 nodes, okay, prices basically, and some instruments and some other things. And then I've also got 293,301 relationships, okay? So I'm gonna first just dive in and show you this this next period thing to show and explain how this works. So here we've got Microsoft, we've got the first 25 days of Microsoft. And so MSFT is Microsoft's, stock symbol. And so you can see that I've got basically a day here. And if I click on this first one down at the bottom, I can see that it's got a timestamp down here, and it's January 2nd of 2019. Okay, and then the next one that's connected is January 3rd, 2019, and then the next one is the 4th, etc. They're connected by a relationship of next period. Okay, and if I highlight that, you'll see that that also has a property on it, and it's got a property called price gap. So what I've done on each relationship in between every node is I've gone in and I've said, okay, what's the price gap between what it closed this day on and what it opened at the next day. So here we can see on this day we had a close price of $101.12, and then we opened on the next day at $100.10. So that is it sunk, it dropped $1.02. From one day to the next. So every single period on everyone has this data in there. Okay, so that's the price graph. Now, then I ran these algorithms, right? These similar, k nearest neighbor and the community algorithm. So let's take a look at that. And so what we've got here is you can see that these are all these similarities between different stocks on different days. Microsoft similar to Microsoft on a different day. Microsoft being similar to Facebook and Cisco and Tesla and all that kind of thing. If we expand this out, maybe instead of showing 25, show 250, we start seeing some larger communities and interesting communities of volume similarity in the graph. Okay, so this is the data that we're going to basically go through and explore and pull into Power BI from this database and analyze. Okay, so let me flip back over here and we'll go back to our talk here. Okay, so before we go look at that, I want to explain a couple of quick things just in terms of the differences between a relational database and a graph database. And so classic example, in a relational database, we all know that relational databases don't really handle many-to-many relationships very well, right? We have to separate things out, right? So in this case, I've got a department that employs an employee. Okay, well, obviously a department is going to employ many employees, and an employee over time may work for many departments in the same company, or they may work in the same department, but maybe they get a promotion, or they may have different roles or different job assignments. So we end up with departments and employees having a many-to-many relationship, right? Which, you don't really do in relational databases. So what you do is you break that out into second or third normal form, right? And you model that out, and you create these what's called associative tables, and you basically create a one-to-many between each of these associative tables to kind of, separate out into a one-to-many to resolve those many-to-many relationships. Well, in a graph database, graphs are just fine with many-to-many relationships. They thrive on it, in fact. And so what you end up doing is you take these associative associative tables, and those become the relationship between the entities. And so you take all the properties that are on those associative tables and you put those properties into the relationship itself. Okay, and then the entities end up becoming the nodes. So you end up with a department employed an employee, and it has all the data from the associative entities in there, and it's just a single simplified relationship. Okay, that's what a graph is and how a graph works. So, which is great, but we want to pull this from the graph because we did all the work in Neo4j. So we want to pull that out of there and pull it into Power BI, which of course we want to get rid of those many-to-manys again, because you don't want to have, you can do many-to-manys in Power BI, but it's not advisable. It's messy, and you typically don't want to do that. So what we end up doing is we have to write a query essentially to get these relationships, extract them out, and create that new associative table to create this, this one-to-many type of a relationship with our stock data for this type of a situation. So that's kind of a walkthrough of kind of the differences there between relational and non-relational data. Now, before I show you the query and we dive in and we start looking at the data, there's this really cool technique that I developed for this, specifically for Neo4j. However, it's something that since I created it, I started using it in a lot of other instances. So many people don't realize that Power Query script is actually a functional language, just like DAX is a functional language, or like Excel formulas, they're functionals, they're functions, they're functional languages. Power Query script is a functional language. And what that means is that you can take one function and you can wrap it around another function to create a single kind of nested function. Well, in Power Query, every time you do something in Power Query, what does it do? Over on the right-hand side, it creates an applied step, right? So what you'll see is that each applied step is actually a function. And since it's a function and you can wrap functions, we can effectively wrap query steps into a single query step to consolidate a whole bunch of steps into one step to make it easier for the user and to kind of create these templates that I'll show you how to do. And so let me give you an example. What we're going to do, and I'll interactively walk through this in Power Query so you guys can kind of, follow through, or you can even do this with me if you wanted to, if you happen to have Power BI up, or you want to open it up real quick while I'm talking. What I'm going to do is I'm going to do a function called list.dates, and I'm just going to create a list of dates. We're going to create a date table, right? Because Power BI, who doesn't need another date table, right? We always are dealing with dates and always need date tables. So one way to create a custom date table is to do a list.dates. And so what we have here is when we do that and we write that function, it creates, our very first applied step in almost every query is source, right? So it creates that source step. And what source is really this function called list.dates. And you can tell it's a function because it's got parentheses surrounding all the parameters, right? So it's just a list.dates function, okay? So you can't do much with a list, so you have to always convert a list into a table so that you can, import it and do other things with it. So the next step that you do when you do a list.dates function is you convert it to a date table. And I'll walk through this and so you guys can see this live. But what you'll notice when we do this is that it creates a table from list, and look, it points to this reference of source. And source is really this function. So what we can do is replace the reference with the actual function and effectively nest it inside there, and then make one wrapped function or one wrapped applied step that actually is doing two things. It's actually doing two steps in one, and you can combine these, right? And that's what we're gonna do. So let's dive in. And so I'm in Power BI, and I'm gonna go open up Power Query. And where I'm going to start is I'm going to just go and create a new blank query, okay? And I don't know how familiar everybody is with Power Query, but one thing you can do, there's a ton of functions, and Power Query over the last year has gotten really, really robust with a lot of new functions. But one thing you can do is you can just type the equal sign, and you can just start typing, and it'll pull up a list of functions that are available. And we're going to do list.dates. Okay, and you can see it kind of IntelliSense prompts you there. So just equals list.dates, and you squish enter. And in Power Query, any function that you type in without any parameters, it automatically gives you this parameter page, this parameter template page that describes, defines what that function does, gives you an example down here at the bottom of how to use it and what the data looks like when it comes out. And then the cool thing is it gives you this little parameter page that lets you fill in the parameters so you don't have to guess about how to do it. And so we're just going to do this real quick. I'm just going to say September 1st. We just want to get a list of dates, and we're going to just do a count. Maybe, so we just want to do 10 dates, and then it's asking for a step. And for step, we could do every other day, every 5 days. We just want to do every single day. So we'll do a step of 1. So starting in January 1 for 10 days, list out those days. And there's an invoke button. If I click invoke, it creates another query called invoked function. Okay, and you can see that it's a list, and we have our list tools up here and our convert it to table button up here for this. But let's pause for just a second and let me show you what we've just done. So in our source applied step, you look at this, and if you look at this up here, I'm going to zoom in just a little bit so you guys can see this. You can see that this is really referring to query 1. Well, query 1 is our other query over here, this function that we were doing. And so if you hover over it or click on it and hover over it, then it actually shows you that what this is actually pointing to that function in that other query. So right off, we can see, geez, not only are these applied steps I was talking about, they're actually functions, but right off, we can see that every query in Power Query is actually just a function. So all these queries that you're writing in Power Query, they're just functions, and they can be referenced or re-embedded into another query, into another function. And so if we go and we look, I'm going to zoom back out. If we go to our view and we just look at our query dependencies and we zoom in a bit here, we see that our invoked function is dependent on query 1, right? Because it's pointing to it. So let's do this first. Instead of doing, let's click on query 1, and you can see that all we're doing in query 1 is just doing a list.dates function. So I'm going to copy that. I'm going to come back over to our invoked function, and instead of query 1, I'm just going to replace that with list.dates. So now we're doing equals list.dates and all those parameters, and I hit enter. Okay, my query didn't fundamentally change. Nothing looks like it changed, but we're now directly using that function. So again, if I go into view and do query dependencies, our query dependencies have now changed. Let me zoom in a bit, and we now see that invoked function is not connected to anything, and query 1 is now standalone. So we've removed that connection. So now, of course, we can delete query 1 because we no longer need it. And now we've got a standalone function. We'll rename this and maybe call it dates. So it's meaningful, but it's still a list. Okay, so let's do this again. Let's do this one step further, and let's convert this list to a table. So I click the convert to table. We're just going to take the defaults and hit OK. Now we've got a table, and now all of our options light up because we can add columns and transform and all that stuff. What did it do? It added another applied step over here. So let's look at this, and instead of looking at it here, I'm going to go into the advanced editor so you can see it a little bit better, and I'll zoom in. And so if we click on the source button, we'll see that it also highlights over here. And what that convert to table did is it ran for us. When we click that button, it ran a function called table.fromList, and its first parameter is source. And source is a function which is list.dates. And as we hover over it, we can see that indeed it's that list.dates function. Okay, so what we can do is combine both of these steps. I'm going to go right after this word source where the comma is, and starting just after the comma, I'm going to highlight all the way, shift highlight all the way over to the beginning of this function. I'm going to cut it, Control X, and then we're going to get rid of this whole step. So I'm just going to delete the name of that step. I'm going to arrow up to the beginning of this list.dates function. I'm going to paste in that other function. And of course, we don't need source now because source was this other function. So I just backspace and get rid of that. So what I've done is I've wrapped table.list around the list.dates function. And we've created a single function, right? And a single applied step. The only thing else I have to do down here in Power Query, the in statement at the end always refers to the last statement in the block. So I just have to change that to source. Okay, and I come down and I hit done, and I'll zoom back out so we can see what we're doing. And now we've got the data is still the same. We've got now only a single applied step. We got rid of that second step, and we've now got both of those things in a single step. Table list from dates. Okay, let's do one more. I'm going to convert this to a date so we could actually maybe like add date columns and things like that. So it did another applied step, change type. Okay, let's go back into the advanced editor. I'm going to zoom in again, and we're going to do really the same thing. We basically see again that source. It's referring back to source. So it's basically saying transform these column types from the source and then convert this particular column over to a date column. So again, I'm going to, starting right after the comma source, I'm going to copy all the way over to the beginning. I'm going to cut that and get rid of our name. We're not going to need that anymore. And I'm going to come up here to the beginning of our source function and wrap it, and then get rid of our comma source. And we've effectively wrapped this again. I'm going to then just again rename our end statement to our last statement, which is source, and click done. And we'll see right at the top up here that we've removed our function on the top left. And oh, what did I do? Oh, I just probably spelled it wrong. Hold on. What did it say I did? Expressions. Oh, source to, oh, I didn't finish deleting all my text there. Sorry about that. Okay, typo. Okay, so now we've effectively wrapped 3 things into this one statement. Okay, well, why do this, right? Okay, really cool, Bryant. You can do this. Okay, yay. Okay, why? Okay, well, here's what's really cool about this. Okay, there's some other stuff you can do that we might. So this function, just take this function in particular. We want to generate a list of dates, and we saw that the inputs for this was a start date and then the number of days, right, that we want to generate. Well, what if I want to generate 3 years of data from a date table, right? How many days is that? I'd have to go and manually calculate and figure out how many days that is, so I knew how many days to generate. Okay, well, let's instead add some parameters. Okay, so what I'm going to do, I'm going to come in here and I'm going to give us a little bit of space, and first thing I'm going to do is I'm going to comment this, and I'll show you what that does. I'm going to do a double slash. I'll zoom in so you can see this a little bit easier, and I'm just going to say enter start date for date table. Okay. Then and I'm going to do a double underscore variable, and I'm just going to call this start date. And the reason I'm using double underscores, in Python we call these dunders, so it'd be like dunder start date, double underscore start date, because visually the users are going to see this double underscore, and it kind of indicates there's an input, there's a blank space there for me to type something in. So I'm doing a double underscore start date, and I'm going to do equal, and I'm just going to give it a date. So since you guys are all in the UK, we'll do this UK fashion, which I think you guys do your dates 2021 dash, we'll just say 09-01, right, in that format. Year, month, day, and then followed by a comma, because you have to have a comma in between each line. Okay, and so then what we want to do is we want to use this start date down in our dates in our list.dates function, instead of right here where it's actually using this start date right here. We want to use our start date. So to use that variable that I just created, I just start typing, and it pops up as like, oh, start date. Okay, I can just use start date right here. Now the problem is there's one thing we have to do, because I'm having the user just type in text for a start date, because that's like an easy thing to just go in and type in that text. But this requires an actual data type. So what we have to do is do a date dot from text function. So again, I'm just wrapping this with another function, and I'm going to just do open paren. Oh, sorry, from text, open paren, and then we're just going to surround that or wrap this function with a date from text. Okay, so now let's I'm going to zoom back out. Let's do just this part really fast, and I'll show you what this did. Okay, so what I've done is I've now got 2 steps. You can see that this first applied step is now this parameter that I just keyed in, and because I commented it, when I hover over it, there's a little eye. Let me zoom in over there so you can see that. There's a little info button that shows up because I did a comment in the query, and it says enter start date for date table. Okay, so it prompts the user, gives them a little bit of a clue what to do. And now if you click on this step, you've just got the text up here, right? And so you can say, okay, now you can do this in US format as well. So I could do like, we'll just say 9/15/2021 and do month, day, year format and hit enter. And then if I go back and look again, now I start at the 15th and I go 10 days, right? So so now the user can go in. So I've created this ability to create like a template, right? And to be able to handle that. So anyway, so let's continue on. So I won't go too much, because in interest of time, I want to kind of get to the other stuff. But just suffice it to say that we could continue going on. We could actually enter in, do the math to do the 10 days as well, which is just an end date minus a start date. We'd have to convert that to numbers and some stuff like that, but it's really straightforward to do. And then we can basically have a set of parameters here that we can enter, and the user can go in and interact with to generate these templates to do a date range, and then you can go on and take these columns and add your add your date columns and do your, your year, your month, number of days in the month, all that kind of stuff. Okay, and build out your date table. Okay, but in the interest of time, let's move on. Are there any questions, I guess, about that first before I go too far? Is any comments on that people had?
Well, great timing and very, very insightful there as well, Brian. We do have two questions. One comes in from Mark Broadbent, and he says, can you please show how you are connected to the Neo4j data source and brought data into Power BI as tabular data sets? He knows Neo4j, Cipher, and Power BI, but as far as he is aware, there is no native driver to do this in Power BI, and he hasn't seen you do this as of yet in the demo.
Cool. Yes, I'm getting ready to do that next.
Fantastic. I thought as much.
So, very good segue.
Perfect. Before we do actually have a question on from Tom on Power Query as well. So we might just jump back before we segue forward, if that's okay.
Yep.
So Tom asks, among other advantages, does wrapping and nesting the Power Query steps make them run faster too? In some cases, he thinks they do. But what's your overall opinion on that?
You know what? I haven't specifically tested performance on nesting or not. I know there's a whole discussion and a whole thing that Power Query does itself, where it goes in and it internally it does a lot of that kind of consolidation and things like that. I don't specifically know if manually nesting those speeds things up or not. It might, simply because it's not going to pointers. It would probably be like milliseconds, but if you have a really large query, it's possible it might speed it up a bit. I don't know. I haven't tested it. I use it mostly to mask complexity. Instead of having 200 steps, right? I want to just have one or two, and then I can share this query, right? The main thing on me doing that is that it gives you the ability in Power Query to write these reusable query templates, right? And so if you go later after the talk, I do have some Git gists with these queries. So to answer the previous question as well, you can just download that query and just pull it into Power BI, run Neo4j, and you'll instantly be up and running and connected. But you might want to understand the query a little bit, which is also why I'm kind of walking through this. One, it's a really cool technique that I use here, and also you can use it to basically build reusable Power Query templates.
Excellent. Yeah. Excellent. Thank you very much, Brian.
Absolutely. Okay, so let's go dive in to the actual query to how I get Neo4j data. Okay, so to kind of preface that, especially for the gentleman who is familiar with Cipher and knows Neo4j a little bit, you're right. There is no native connector. There's a third-party connector that I can't remember his name. I've got references to it in my one of my Medium blogs on that. But it's a custom connector, and so you can do it locally. But if you wanted to publish it up to Power BI Online, it wouldn't work. So the only thing right now that actually works to allow you to do data refreshes is to use the REST API, or in Neo4j, they just call it the HTTP API or the web API. And so that's what I'm doing. And that's what my query is. And so I'm going to real quickly walk through this. So the query that I have here, I've written essentially a single query template that goes and uses the web API, Neo4j's web API, to connect and get data. And so it's using a web contents function in Power Query. And you'll see all these double underscores to the Neo4j URL, the database, the username, the password, and the Cipher query. Okay. And so what you'll want to do on your Cipher query is don't return nodes and relationships directly as objects. You want to just always return properties. I have another set of queries that can return the object itself as well, but then, relationships come back different than nodes. And if you do a path, that's a different kind of it's a whole different JSON structure, and it's messy. So the easiest way to do it is just do your Cipher query and do whatever node.property or relationship.property and return the properties. Okay. And that should be your Cipher query. But the trick, there's two tricks here. The first thing is that Neo4j requires a post web call And Power BI by default does what's called a get call. So a get in kind of web programming language, a get call is basically when you go into your web browser and you type in a URL and you get to a website, you're doing an HTTP GET API call. You're doing a GET call to say, get me that page, get me that data. And that's what Power BI does by default. But to use the Neo4j interface, you have to use a post. And so in Power Query, there's a parameter called content. And you just simply have to specify the content parameter, and then Power BI knows to make it a post call instead of a get call. And that's really the trick. And what we're posting is our Cipher query. Okay. The only other thing that's special about this is that Neo4j requires you to do an encoded username and password. And so to do that in Power Query, I've done this binary to text, text to binary, binary to text, kind of a double wrapped function there. And I'm just passing in the username and password in that, it's called basic authentication, basic auth, and there's documentation on the web about that. But it just literally says basic space and then the 64-bit text binary, hash, if you will, to pass the username and password. Okay, so that's the query. So with that, let me flip back over here, and I'm going to now show you the query, and then we'll go in and actually start looking at the data. So in the query, this is my template, okay, my Neo4j template. And so what I've got here, again, we've got all these double underscores over here. I'll zoom in so you can kind of see that. And I've got, again, my comments, enter the base URL for the Neo4j server, enter the name of the database, the username, the password, and the Cipher query. So when we click on these, I'll zoom back out here. Again, I'm just using my local database, so it's just localhost and then the port number, which is 7474, default port number for Neo4j. What's the database name? If you're running multiple databases, you just type the name of the database there. I'm just using the default one, which is Neo4j. My username happens to also be Neo4j, and then my password for this database is stocks. So I'm just typing in my password there. Then I do my query, okay, my Cipher query. And so the Cipher query is just literally an exact Cipher query. So I'm just doing, in this case, a match statement, and I'm returning certain properties. I'm going to copy this really quick, and I'm going to show you that this is just a full, whoops, I hit the wrong one here. Let me go over here, and I'm just going to paste this in. And hit enter and run this to just show you that really all I'm doing here is I'm just literally running a pretty generic here. You know what? Let me stop. Oh, well, it did it. Okay, that's cool. I was thinking it might have returned a lot of data. I was going to limit it, but you can see that really it's just returning columns of data, right? Because I'm just doing basically just my relationship names and things like that, right? So that's how you want to do it. You want to basically do it where you're returning just kind of like table data, right? Because we're in Power BI, and so I could, if I wanted to look at this, instead of returning all of that stuff, I could just return my whole path, if you will, and instead of getting all the data back, I'm going to just limit this really quick. I'm just going to limit it to maybe 100 real fast, so it just runs a bit quicker. And then here we've got, this is just that same query that's basically showing those volume similarities. In this case for Microsoft, it's showing me the first 100 clusters, right? So it's just whatever you run in here, you can literally just get it set up the way you want it and just copy and paste it then over into Power BI or into Power Query and run it. So what I've done then is I've made this as a template query, and I've set it to not load. And then all I got to do is duplicate it, right? And now I rename it and I change my query, and I pull in the next thing. And I've basically just done that over and over again. Okay, so I've used it to then do my price history. So you can see all the way the first steps up here, all the way to Neo4j. These are just the template, and you can see that it's basically just automatically pulls in all of those things. And if I expand this out, you can see that it's doing the web call, and then after that, and that's pretty much what it's doing. And then after I did that, I've got some other things I've got some data. I wanted to know what data types were, so I kind of, this indicates this is a real number, this is a time stamp, that kind of a deal. So I do some extractions, and then I just simply change the data types, and I added in like some additional columns over here for like the name of the month, the quarter, and that kind of a thing. But really, the whole query is just by Cipher Query, and then whatever else I might want to do in there. But I've eliminated and consolidated all that into this one Neo4j results step. And it's really doing about 10 things. It's walking through that JSON structure and doing all that for you automatically, and then I can just deal with the data and then get the data. So I've done the same thing for the relationships. Here's the relationships, the start node, the end node, and the volume similarity score. And for next period, same deal. And I've got the price gap in here. Okay, so all of that ends up being no, I don't want to apply, and ends up being here. Let me get out of this really quick here.
And Brian, just on that note as well, in terms of that connection, obviously it's a web-based through the API. We have a question, and they ask, would you need to use a data gateway to access the Neo4j server hosted on-prem when coming from the Power BI cloud?
Great question. And it depends where your Neo4j server is. If your Neo4j is on-prem and you've got it on a server, then yes, you would need to do the data gateway. If you're doing it personally, you can set up the Power BI personal gateway and access your local server, that way. If it's on a network at work and it's on a local network on your there, then yeah, you would need to just activate the Power BI gateway and access it through there, just like you would any other server, right, on-prem. If it's hosted instead up in Azure, then you don't need to, because Power BI is already in Azure and it can already connect. You just need to give it the server name, the connection criteria, and just like in SharePoint. If you use a SharePoint list or library as a data source, you don't have to do a gateway at all. Or if you have an Excel file in SharePoint Online, you can just go point right at that thing and grab it right in Power BI and do data refreshes. So yeah, so it just kind of depends where you're hosting your Neo4j server. Yeah.
Excellent.
So, okay, so with that, yeah, go ahead. So now we've got the data, and we've basically got this is what it looks like. We've got our price history, we have instrument data, which has all of our fundamental data, and then all of our period information and things like that, right? So were there other questions? I'm sorry, Leon.
None currently, no.
Okay. So what I thought I'd do then, I'll take run a little bit behind here, but I want to kind of showcase what this data looks like in Power BI. And I'm going to show you, I've actually published this up to Power BI Online, and I'm going to just show it to you up here. So the first thing I'm going to do is I'm going to go in and look at this data. And we've got this first screen here. I'm looking at high-low volumes. I want to kind of zero in to see if there's an area of time that might be of interest. So I'm going to use Power BI to do some analysis, some insight-driven analysis. And so I've got right here, I've got a listing of all the highs and the lows of all the stocks. Okay, and so right now I'm not filtering anything. So this is effectively all 34 stocks that I have in there, and it's the highest highs and the lowest lows. And so what I can see is that there's a big dip here in this range around kind of 2020, end of March, beginning of April, kind of in that timeline. So I'm going to come down here, and I've got those volume communities that were created with that machine learning. I've got those indicated down here on kind of a timeline. And I'm just going to kind of zoom into a section here. And we're going to just look at this area in here. We're going to pay attention as I select different stocks to see how much volume similarity interconnection there is. And let's just pick, we'll pick Microsoft. Okay, and we see that with Microsoft and maybe NVIDIA. We start seeing that there are indeed a lot of colors, a lot of different groupings and things like that being tied together in here. So it looks like there's at this point in time where there's this big bottom in the market. This is, I think, the COVID bottom that we're looking at. There's a lot of similarity going on between different stocks and different things. So let's dive in and say, okay, let's take this time frame and go in and look at this in a little bit more detail. And let's look at those volume similarities, okay? And so here I've got the stock chart, and I've got our volume similarities, and I've got some other matrices and things here to kind of help me fine tune and see what else is going on and different things. And what I'm going to do is let's clear this out. And so first we can see that overall, so I've got the same time frame highlighted up here, and we can see that overall for everybody, for all, even though it says Apple, ignore that because I don't have anything selected, and I need to fix that. But anyway, but we can see that we have like just overall in the market, we have a lot of different things going on here, and we can kind of see that there's bottoms. And we also see down here that we have these similarity totals, or these similarity scores, and we have spikes in these similarity scores. So if I look at something interesting in this stock where we've got kind of a spinning top type of a deal that looks like it might be on a bottom, and I highlight that, I can see that there's also a volume correlation spike on that day. Okay, and then there's some other ones. So let's go and pick specifically somebody. We can look at, we're looking at Microsoft. I'll just keep looking at Microsoft. And so we can see that that Microsoft has some of these spikes as well. And I can't remember if it's, I'm going to click on one of these. Yeah. So this bottom right here is showing a pretty significant spike here at the bottom. So it looks like what these volume similarities have done for us is they've consolidated and looked at, hey, there's a lot of activity going on. It might indicate a support line, a resistance line, a top or a bottom. Okay, and so we can kind of go through and look at these different significant events here, or sections, and it kind of looks like, again, this is something where it's showing kind of a support line or a resistance line, and if we expand this out a little bit, we can kind of see what indeed, if I move it forward a little bit, we can see what indeed it ended up doing, and it looks like it did indeed form a support line, right? Right there at that spike. And then we've got other ones. Here's another big one right here at the end here that looks like it's, again, potentially another support line. And if we kind of expand that out, it did indeed jump up another, $15 right at that point. So we're kind of seeing some correlations, but it'd be nice to know for sure if if these are real, or if we could statistically define these and look at these. And so let's go look at some different, correlations. And so what I've done here on this piece is I've got a correlation matrix. And again, this is right now, I don't have anything being filtered. I've got kind of a graph relationship of the stocks and the relationships here. So let's go and let's again pick on Microsoft. So I'll pick on Microsoft, and we can look at their correlations specifically for this time range. Okay, and so we can see over here that we've got some similarity with Moderna, with Tulsa, with AMD, with Apple, and that kind of a thing. And we can specifically go in and look at those correlations between say Microsoft and Apple in particular, and we can see that we have volume similarity scores between Microsoft and Apple, between a negative correlation with the close and a negative correlation with both their volume community and their similarity score, as well as their similarity labels. So it looks like statistically we have statistical correlations between these things, between these stocks, between these stock volume trading types of information. And we can go and due to time, I'll open it up for questions, but I'll show a couple of other quick things. We can also further drill into those correlations and examine them further to see like which stocks tend to correlate together, so that I can look at maybe how to maybe improve my trading and that kind of a thing based on stocks that correlate well together. And so here I'm showing some Python. I don't know why this one's not loading. I guess it's a Python. It's a Python correlation matrix. And then what I've done here is done some Python as well, where I'm just basically showing kind of if you can imagine a 3D distribution, and then looking at a slice from the top, the bottom, the left, and the right, and then just breaking those out into a flat. And here we're looking at Zoom, Adobe, Microsoft, and some of those to just look at how they're distributed, to kind of look at areas where say like Apple and what are we looking at? Apple and AMD and some of these tend to trade together. They tend to be, similarly distributed, have similar distributions among those. And we can do a more interactive version of this as well, just looking purely at distributions using just the native Power BI scatter plot, visualizer, and oh, of course. So, we have network issues or whatever, but so it's taking a second for us to load. I don't think it's a Power BI. I think it's just probably network or whatever issue. But we can further drill in and look at these from a variety of different areas to find pockets or groups of stocks that maybe correlate well together and that kind of thing. Yeah. Okay. So with this, especially since it looks like we're having a few issues here anyway with pulling some of this up. I'll open it up for questions and talk through and if you guys are interested, the Python code is literally about 3 lines of code that I wrote for those Python ones. Okay, we'll just come back over here and look back at our Similarity screen here. Okay, but yeah, are there questions? I'll go ahead and open it up and try to answer as many questions as I can here in the next 5 minutes. So
no problem at all, Brian. Absolutely. Like I say, fantastic session so far. We have a short delay in terms of our live, so we're probably about 10 seconds behind. So as Brian has mentioned, if you do have any further questions, then please do put them in the Q&A now, whilst we just await the feed to obviously catch up. Whilst we do that, Brian, then please, by all means, if you do have some of the Python script for some of those visuals available to show us. I know it's 3 lines, but obviously for some people that don't use Python for visuals, it will be very interesting.
Absolutely, I will head over to show you that. Let's see here. I think that was my time series that's in correlations. Okay, so yeah, here's my Python. I'm in Power BI on here, and literally as that loads here, I'll show you that for the most part I'm just using Seaborn and matplotlib as a so I'm importing Seaborn and matplotlib library called matplotlib, and you can see that other than my import, it's literally 1 line of code. You have to, in Power BI, to show anything, you always have to plot it to show it. So that's a given, and then you obviously have to import what you want, and then all I'm really doing is just doing a Seaborn pair plot of my data set based on my ticker, right? That's it. So I've got my price, volume, and different things over here, and it's literally, in this case, 1 line of Python code, 4 total if you count all of them, right? And then that's for this distribution curve. For this other distribution, it's kind of the same deal, but it's a scatter plot distribution, and it's pretty much 1 line of code as well. There, and then I think this one is using Seaborn as well, and it's got a couple of lines of code, but basically just to format the properties and then write the one line of Python for that. And then the one that's not working is my it's doing a data frame, and it's got 20 lines of code, it looks like, total. So so that one's the most complex one, and but yeah, it's really just it's the same as that scatter, or as the that matrix I was doing, the correlation plot that you can get in the marketplace. Other than this page, all the other visuals I used are completely from the app space, just downloaded right from within Power BI, and they're all available out there. So
excellent, thank you. And we do have a question come in, and they ask, the most important question is, have you made any money trading using your data analysis data?
You know what, I have a little bit. So yeah, it's I've found that particular indicator is it doesn't necessarily get your timing exactly right, but it says, hey, something's about to happen. And so it's another indicator, right, to kind of add to your tool set, to basically say, hey, this is probably a bottom, or this is definitely a very strong support line, when you're looking at those things, and, and it's another tool in the arsenal, right? So
exactly.
So insightful, for sure.
Fantastic. And I have a question off the back of that as well, is how many times have you been asked that question before in a webinar?
every time.
I was going to say, because as Mark mentioned,
I'm not offering any stock advice, although, you could probably use this to gain some insight,
Exactly, just to be on the safe side. But
right.
it appears, Brian, from our perspective, that that's been all of the questions wrapped up. It seems for our user group, a lot of the questioning came around actually connecting with Neo4j, understanding that perspective, and also some questions around obviously the Power Query magic.
Yeah. And Neo4j, you can anybody can go and download that for free, the desktop version, and run it personally, and do that and play around with it and do like what I've just done as well. But to run it in production, you do need it obviously requires licensing and that kind of a thing. It's a full-blown product. So I've tried to just use everything that you guys can do kind of on a free basis to kind of experiment and play with it. And that type of a thing. Neo4j is pretty easy to get data in and out of. For Power BI, the reason, again, that I use the web API is so that I can publish it up to the web. Everything works, and everything can be auto-refreshed on the schedule in Power BI Online using the web API. Whereas several of the other solutions I've seen out there for pulling stuff into Power BI, you can't auto-refresh them, and that's why I specifically went this route. So, yeah.
Yeah, that makes perfect sense. And like I said, I personally want to thank you for fitting so much information into such a short period of time.
Absolutely, it's my pleasure again. And if there are questions, feel free to reach out. And again, I do have. Let me run this just as a final thing here. I'm on Medium at Bryant Avey, and again on LinkedIn. And I do have an article out on Medium called "Importing Neo4j Graph Data with Power BI." It covers some of the stuff that we just saw here today and does a walkthrough. The links to my gists and the code and stuff, those Power Queries, is all there. So just go to Medium and look me up, and feel free to connect with me on LinkedIn as well. Happy to connect and share whatever I can. So.
Excellent, thank you. And I have posted your social media links into the chat as well. And some of our user group are coming through and really thanking you for such a great session as well, Brian. So we really appreciate it.
Thank you. I appreciate it. Have a good evening, everybody. I appreciate it.
Thank you, and the same to you. And once again, thank you for everybody for joining us at the Microsoft Power BI UK user group in association with our sponsors, Onyx Data. And again, I'd love to thank Bryant Avey for being with us for such an informative session on Neo4j integration with Power BI. Thank you, everybody. You could have been anywhere in the world, but you've been here with us.